So welcome to our second session in a series of sessions designed for our community to build capacity in Ontario and even beyond for coding FRC robots. You'll find a few new features to our series of coding sessions this week, and hopefully everyone will have a great time. And please feel most welcome to ask questions in the chat, and maybe we'll pause a few times in case there are some questions. So let's get right into it then. Our introductions and schedule we did last week. There are a few new participants this week. So just briefly, I'm William Neal, the Program Manager for First Robotics Canada. And this series of coding sessions is hosted every Monday evening on this Zoom call from now until about mid-December, and we'll resume in January and go to the end of February preparing teams for the competition season, which will be in March. The intent is for the first several sessions to be quite introductory, as many of the members may be new to coding. So the content is introductory, but as we move along, we'll install some of the software associated with coding in First Robotics teams. And then by the end of this series, before December, we would hope that everyone has at least a good background with some basic Java coding, and we start to relate it then to the coding in the robots. After the build season begins, then we will move towards a more advanced set of topics that will help teams perform special functions on the field, such as vision processing and something called PID and the like. All right, there's our schedule, as was just discussed there. In the meantime, while we're doing our introductory sessions, it is hoped that the participants will install FRC Java, and you may search online for this to find a place to install FRC Java. All right, there's our schedule, October to February. And last time what we did, just for the sake of those who were not here last time, we had an introduction to ways to learn computer coding. And then we had a little introduction to FRC Java and the installation of FRC Java and software deployment. There was a little diagram, which will be updated this week. Basic program, hello world in Java, and then syntax, comments, variables, and data types. And if you missed the content last time, most of you will have received links to the previous session's video and even slideshow. If you didn't, let me know in the comments, and we'll see if we can paste these in the chat before the end of our session this evening. Here we go with a slight update to our vision for what we're doing here in our FRC Java sessions. Last time you will recall that we were looking at a computer such as a laptop or a desktop, and we have two special programs on there: the driver station used to drive the robot, and VS Code, which is a special integrated development environment where you enter your robot code. And wirelessly, that attaches to a robot through the radio, which is a wireless router, and that connects to the robot's central processor called the Roborio. And presumably on that Roborio, you will have Java, though there are other languages you may have. And there is a possibility you may have a code processor if you're planning on doing vision processing and some advanced robotics work. What I added this week is GitHub. One way that computer code is shared is through the site called GitHub and many other similar sites. This allows us to work on code in a team in such a way that if one file is being modified by one member of the team, there's little or no danger of that file being altered by another member at the same time, which would result in a disaster. The way that's done is through branching of the code. Everyone works on their own branch. And when the code has been verified, it can be imported into the main branch of the code. And robotics teams are encouraged to use GitHub so that they may share their code and they may work in a team effectively and communicate effectively. And the code that we accumulate during our time here will eventually be put up onto GitHub as we start to get some more significant code. This will help us to share amongst our community our various approaches to various Java tasks. So an update to our vision then is A, to develop the software, and B, back up and collaborate on GitHub. If you store your code on GitHub and you lose your computer, well, there's still a backup of your code online. And then deploying to the Roborio and testing with the driver station. So one more item added to our list of tasks that we will hopefully accomplish by mid-December. Getting right into our content for the evening then, bits and bytes, data storage units. And today's theme will be all about how data is stored in our Java programs, and then a little bit about some of the basic commands that you will find in Java programming. Right here, we have the definition of a bit, which is a 1 or a 0, and that's a very familiar sort of image if you think about computer programming. Computers store their data in ones or 0, or that's at least how we logically think about it. It's through electrical and magnetic modifications to some kind of medium on the computer, but we think of them as ones and zeros. And then we organize them in groups of 8. So 8 bits is a byte, as you may know, and there's an example of a byte, 1010, 1110. And how does that work? Well, here's a little bit more about how variables work in Java. There are some typical variable types in Java, and beside each is an indication as to how much memory is taken up, how many bytes are used by each of these data types. So the very most basic one is the byte, and it takes 1 byte of memory. It has 8 spaces or 8 bits inside it. And so a byte is 8 ones and zeros altogether as 1 unit. And it's stored in a variable called a byte. So a short integer is generally a positive or negative number stored in the computer. And there are 2 bytes in the short integer. And if you know a little bit of binary mathematics and a little bit about how these variables are stored in the computer, you can calculate how many short integers can be stored in 2 bytes. And you can look that up by going onto the internet and looking up encoding as a means of storing information within bits and bytes. It's an established arrangement of and meaning of bits and bytes within a computer program. A character is a text character, and that takes up 2 bytes. That's a very simple explanation of text characters, and you can learn about standard ways of storing text characters in computer systems. A long integer is 8 bytes, quite a lot of information. And then we go back down to a very simple one. The simplest one out of all of them is a Boolean. A true or false value is just 1 bit. A single 1 or a 0 is enough to store a Boolean value. A floating point number is familiar for any of you who know numbers with decimal places. So that's the equivalent of a number with a decimal place in computer coding. And then a double is just a longer floating point number. And you will need to be familiar with at least a good number of these if you're doing FRC coding. Some values, for example, how fast is the motor, or how much power is being given to the motor controller, well, that's usually a floating point number or perhaps a double number, depending on, actually, I can't quite remember. It's one of those. But you put a number between -1 and 1 with decimals into a variable to set the level on the motor, for example. And is the switch on or off? Well, we can use a Boolean in our robot to decide that. So more examples for sure will come from all of these. A string, it's an array of characters, and a string is capitalized because it is a composite of individual characters, and that was clarified by one of our participants last week. In Java, any variable type that has all lowercase letters, like the ones you see here, are all basic types and cannot be broken down any further. But a string is a collection of characters and therefore is a composite data type and is therefore capitalized. And that can help you to keep things organized. That's a good place to stop in case there are any questions. And also, I think it's also a good place to really emphasize when you're Java programming, along with several other types of programming like Python programming and C programming, case is very important. They're case-sensitive languages. A capital S is distinct and different from a lowercase s, and therefore you must be very careful that you get your capitals and common characters all worked out. There we go with now a few questions. So now just going to review a few of the comments here. The video, I'll make an effort to post it later, and I'll put it in the chat. Oh, can't hear anything. I hope everyone else can hear everything. I do have my microphone on and it was working before. And VS Code is Visual Studio. That is indeed correct. And that's the one that is supported by FRC. We use Visual Studio Code as a community because they've selected it as one integrated development environment for which to write special code. Oh yeah, there it is right there. There's VS Code. And there are special libraries for FRC robots, and you will see those when you go to the website and begin downloading. Just double checking our participants here. Yeah, there's no one in the waiting room, and our chat. Yes, the first few meetings are for beginners to coding. At 8 o'clock, between 8 and 9, or 8 and 8:30, I'm glad to go through some more advanced topics. As we advance through the year, we're going to go through more advanced topics. So I think someone is helping someone else with a mute. Hopefully I'm not mute. I think I'm not because people seem to be responding. Oh, it looks like it's working. Great. Long and int being different sizes in Java. Oh, that's interesting. I wasn't aware of their exact sizes in C and C++ because I haven't used those since the 1990s. I'd forgotten that. So that's something interesting that we may look into. Ah, there we are. And there's some very useful information about how long integers may store numbers between negative and positive 9. Whoa. That's a billion, trillion, quadrillion. Well, is it quintillion? Well, any very, very, very large numbers because of the number of bytes involved. So the bytes and bits are just ways to organize our information in a computer program. And we may be able to see how they get assembled into actual computer code. For example, when we take a look at a little program, and we will, maybe we can imagine how the bits and bytes are related to that program. You may have to take some computer science courses to get into the details, but we can speak in general about how that happens. And would a Boolean variable be used for creating a physical movement or only understanding what is happening through your code or what is happening? Well, it could be both. For example, you can have a statement, if move equals true, or if move is true, then set the motor to 100%. If move is false, then set the motor to 0. So it is possible it could be physical movement. I'm responding to a chat here. A Boolean variable may also help to understand what's happening. For example, the Boolean can be an indicator for whether a sensor is on or off. So some great questions, and I guess we will continue.
I have a quick question.
Sure.
I'm wondering if there's a standard for the Boolean which 0 equals false standard, or if it matters?
Yes, 0 is typically false and 1 is true as far as I know, at least from what I've seen in other languages. And as for why, I'm not quite sure, but that is as far as I know. So I think you can replace, in many languages at least, a false with a 0 and a true with a 1. And that's something we can try in our Java and see if it works. I'm not going to comment because I haven't tried it lately. I know in Python it can be done. Python's quite easy going about data types though. So I'm not going to comment about Java until we try it a little later. True and false, no caps. And that's a good point, Peter, thank you. In Python, true and false are capitalized. In Java, they're not. So we have to sometimes keep track of these things in various computer languages. All right, Java operators. In here, Java operators are some of the basic building blocks of computer code. And they allow us to do various functions in a computer program. For example, we may use them to set the values of variables, perform mathematical operations, compare two variables, make logical decisions about variables. And there's also something called bitwise operators, which are probably a little beyond what we would need to know right now. And they move around the ones and zeros in bits and bytes, performing certain operations. And we'll just take a little look at each of these this evening, particularly the first 4 or 5 of them are rather important. Bitwise, well, maybe, depending on what you're doing in your computer coding. All right, so let's take a look at those various operators. The assignment operators, they allow us to set the values of variables. So what I will do now, I'm just going to go to my online Java and take a look at some assignment operators. So how can you learn about assignment operators? Well, one thing you may do, here's an example website. It's a great tutorial, and it lists out the various operators that we'll be talking about this evening. And you can use this as a reference. And we may not have time to go through all of these, but this is something that will serve as a reference. All right, let's go to our program now, and we will do some work with some variables. So what about an integer? All right, there are a few assignment operators, basic assignment operators. I'm also declaring variables in the same line. So the equal sign is your basic assignment operator, and it's the most commonly used, perhaps, depending on what you're doing, I guess. That's the first one I remember learning when doing various other languages. And it allows us to set a variable to a particular value. And then we will be able to see these values by system.out.println, which we saw last week, which allows us to print the values. So there's float number. Always remembering our semicolons. Had to remind myself several times today to do that. Copying and pasting can save us a little time, depending on what we're doing. And we'll look at the number and then the switch on. You'll notice I'm making an effort to be very particular about capitals, as much of our FRC code uses a similar convention. First of all, the variable names are descriptive. I don't just say n or x, I say float number and number. Maybe number is not that descriptive. I could call it some number, for example.
You'd call it integer.
Yes, I could. Oh, if I call it integer, I'm a little afraid of doing that. Well, let's try calling it integer and see if it will let me. I'm afraid of that because it sounds like it could be a reserved word. Well, it's looking fine. There, that's good. Integer equals 4. Okay, a little more descriptive. We still don't know what it's being used for, but at least it's a little more precise. The point being, be clear as possible in your code so that other people reading your code may make use of it. And it looks like our code has worked. We've printed out the values of the 3 variables, and we've used assignment operators to do that. So one of my favorite sort of features of languages like C and Java is this one. Here's an assignment operator, which allows us to increment the value of our integer. Those little pluses at the end actually increments an integer by a value of 1. And we can go in the reverse by just using a decrement operator, which is the double negative sign. Now, if we run our program, we should see the integer temporarily takes on a value of perhaps 5, and then returns to the value of 4. And we can experiment with some different assignment operators like this. So here's one. We can combine some arithmetic operators. I'm integrating these in here. And that with an equal sign. So times equals 6 will multiply the integer by 6. And then minus equals 23 will subtract 23 from the value. And see if we can follow our integer along here. We multiplied our 4 by 6, we got 24. We subtracted 23 to come back to a value of 1. These are several of our integers. Now here's something to really make math people really crazy. We're going to do this. Integer equals integer plus 17. Wow, that is actually a little bit of a problem if you've gone to math class. Anyone who's gone to math class knows that the left side cannot equal the right side. So we would actually use a not equals to sign here if we were in math class, but in computers class, we can get away with this. There is a reason, because this assignment operator, this equal sign, goes like this. It's not a math statement saying the left side equals the right side. You may read it like this. The new value of integer is equal to the old value of integer plus 17. So there's a time sequence. This is the new one, and this is the previous one. And by thinking about it like this, hopefully we can satisfy the mathematics people who will otherwise be quite out of sorts with this statement, which is not true in math class. So we read it once again like this. The left side is the new value of the integer, and the right side is the old value of the integer. And again, maybe math students might think about this. Well, what about this? Integer plus 17 is equal to integer. You're thinking back to your math rules. If A equals B, doesn't B equal A? Well, we may find out here if it is. I don't think so. Let's just double check that. I think it's going to give us an error here. And let's try running it. And integer, oh, there's an error. So it took exception to my use of a plus 17 on the left side with an equal statement. You can only have a single variable name on the left side of an equals or an assignment statement. So I have to use something like this. All right, so these are various assignment statements. We will put that there. And you may experiment with these again by going to various tutorial sites and just trying the various assignment operators to manipulate the values of your variables. Here we go, just running this again, seeing if our code works now. And it looks like it's fine for the moment. So inherent in my use of these assignment operators has been my use of arithmetic operators. So plus and minus, and multiply is an asterisk, and divide is a slash. And there's also something called modulo, which is a percent sign. It's like the remainder of a division. So let's try this. So I'm declaring A as 5, and then B is just A plus 3. And I'll use a negative sign. And how about a multiplication sign? And a division sign. Oh, that's interesting. I'm taking an integer 5 and I'm dividing it by 7. Well, let's see what happens there, if it will let me even do that at all. The other operations are all going to be integers. Just adding, subtracting integers brings us more integers. But if I divide two integers, I don't necessarily get another integer. And there I have the 5 variables I just declared. I may get an error here. Let's see. Well, it's looking like 5, and then 5 plus 3 is 8, and 8, or 5 minus 4 is 1, and 5 times 80 is 400. 5 divided by 7 is actually not 0 if we think about decimals, but if we think about integers, it is 0 with a 5 remainder. And that brings us to our final arithmetic one that we'll consider this evening. How about F is equal to A percent 3? And that's like this. We have 5 cookies, and if we give them out to 3 people, how many will be left over if we give as many as possible? It's the remainder of a division, essentially. So 5 divided by 3, what's the remainder? Let's see what that is. And it should be, hopefully, 2. Oh, A percent 3. Oh, that's sort of strange, isn't it? I'm maybe confusing that with another operator. Okay, well, this is where we can go and find out. Arithmetic operators returns the division remainder. Okay, it's supposed to return the division remainder. Oh, that's what happened. I didn't print it out. Now we should see the division remainder of 2 come in there somewhere. And there it is. All right, that's a little discussion about arithmetic operators and assignment operators. How can we establish the values of variables, and how can we manipulate the values of variables using various assignment and arithmetic operators? All right, now we have a few more questions here. Oh, we've got a discussion going on here. And we're talking about the age-old challenge, which is the single equal sign versus the double equal sign. And that's a really good thing to remember. And we will see this momentarily when we consider comparison operators. Yeah, so that's great. A good discussion is going on here. Thank you very much to the friends in the chat who are having a nice side discussion, which is enhancing our discussion here. So that's great. We will consider now We've gone through a little bit about assignment operators, comparison operators, allowing us to compare two variables. And we will go back to our Java Online here. What I'm going to do, I think I will take this code and save it for later and maybe post it somewhere. There, I'll be able to post this somewhere so we can reference our code a little bit later. That's perhaps not the best place to be posting code. Google has its own ideas about what code should be doing. So maybe I will start a new file here just in case. Post the code here. Okay. All right. Come back to that in a little bit, and maybe we'll post that for future reference. So now we can feel a little bit more free to start again with our code. And a little cheating here, just keep the main class on the editor, in the editor here. And there we are. We should be able to start once again. So now assignment operators. Oh, I'm sorry, we just did that. I meant comparison operators. So are two quantities equal, or is one greater than the other, or one not equal to another? Well, let's see. First of all, we'll just do two simple variables here. A is equal to 5 and B is equal to 6. And then we're going to have an expression to evaluate. And this is interesting. I'm going to print A is equal to 5. And that's an interesting thing. How can I print an entire expression like that? Was it going to print A equals 5 on the screen? Well, let's find out. It's true. And that's the whole point of the comparison operator. It's answering a question about our variables. It compares two variables and provides an assessment or an answer about that comparison. So in short, it's going to compare them in some way and then return true or false. And let's try a number of these comparisons. So one of your most common errors in early computer programming language acquisition, beware of equals versus double equals. Especially if you've been programming for a while, like when I grew up, they both meant the same thing, or one equal sign meant either comparison or assignment. But in more modern languages, they adopted the double equals to avoid lots of confusion, I suppose. So just be aware that a single equal sign is an assignment and a double equal sign is a comparison. Some other comparisons that we can look at, greater than or less than. And we can also look at greater than or equals or less than or equals. So there's less than 5, greater than 5, less than or greater than or equal to 5, and less than or equal to 5. And let's try all of those. Which ones are true and which ones are false? We'll get a series of trues and falses. So there we are, a true and two falses. And because of the equal sign, then we're getting that. Well, let's try a few other things that we could do. What about A greater than or equal to B? That is probably true because 5 is not greater than or equal to 6. So there should be a false coming up here. There's a false to verify it. And then some curious and playful computer programming people might remember math class and try something like this. How about 10 greater than or equal to A and greater than or equal to 5. The mathematics people are always trying to find out how their math is related to computers, and sometimes they're disappointed, like here. You can only compare two variables here. So what you may have to do is to use another technique if we want to find out if A is in this range between 5 and 10 inclusive. And also it's written backwards. Probably should have started with 5 and gone to 10. But you can try it. It still won't work, is my guess. So how can we do that? We'll be getting to that in just a moment. But we're going to try one more thing here. How about A not equal to 5? And that's going to be false because A is equal to 5. But we could try B not equal to 5. And we should get that B is indeed not equal to 5. So that's true. Okay, and just a little note about each: equals and less than and greater than and greater than or equal to, less than or equal to, oh, there's another greater than or equal to, and not equal. So there we have some comparison operators. And of course, the internet is a ready repository of much more information about such things. So the assignment operators are here, the comparison operators are there, and oh, they've only done those ones. I suppose that's the ones we need for comparison operators. All right, we come back to the idea of what happens if we want to check if A is in a certain range. So we're going to look at logical operators. And these ones here you have seen, possibly, and, which is indicated by 2 ampersands. And then we have or, which is denoted by 2 pipes. That's the little key beside the enter. And those are very commonly used logical operators, and I believe we should be able to use the not, which is denoted by a exclamation mark. It negates whatever comes after it. Let's see these in action. So we wanted to check if A was in the range of 5 to 10 inclusive. So we could try this. We're going to try A is greater than or equal to 5, and A is smaller than or equal to 10. See if that will work. There we are. And there is a way to check whether A is in a certain range. You have to check each of the 2 endpoints individually. Okay, this might be a good place to pause for any questions we may have. Excellent. So there's some great general computer programming questions coming up here in our chat. We will then return for what is our next little topic to discuss. We've talked a little bit about comparison operators, a little bit about logical operators. it does appear that we should have an or and a not for an example. So how about this one? How about this? Or A is greater than 10, less than or equal to 5, or A is greater than or equal to 10. At the moment, since A is 5, that will be true. So I'll try that. And this should make it false for the moment. So is A less than 5, or is A greater than or equal to 10? No, not at the moment, because A is 5. However, if we make A 15 and then try again, is A less than or equal to 5? No, it's not less than 5, as it says there, but it is greater than 10, so it's also greater than or equal to 10, so that's true. That's the use of the or statement, and not. And I'm going to test this here. I don't know if I need brackets around it. Maybe I do. I have a suspicion that I may. I'm going to put brackets around this because this should help me to make sure it's applying to the entire expression. So the expression is A is equal to 5, and we already know that, well, it was 5. Let's put it back. Now it's 5. But if we say not equal to 5, or not A equals to 5, that's the opposite. So at the moment it's true, so the opposite will be false. And just testing, we should see a false show up at the end of our output. Yes. So this not, it negates a Boolean expression. It turns true to false and false to true. There we are. Some logical operators, and that goes along with some comparison operators. Knowledge of these operators is very helpful for many other topics that show up in our computer programming. All right. We have now seen assignment operators, arithmetic operators, comparison operators, and logical operators. This last one here, the bitwise operators, you may take a look at them on the website, but they're slightly more advanced and may not necessarily be useful for all manner of introductory FRC programming, but they're there for you to learn. Binary numbers are involved, and we could go into this as a side topic if there is enough interest in our chat. All right, we now move into some Java arrays and lists. And to demonstrate this, I'm going to show and remind of some different ways of learning code. So far this evening, it's kind of like grammar. We're going through a little bit of grammar. These are the building blocks of computer coding. Meanwhile, sometimes one way to look at code and to learn is, or one way to learn from code is to look at assembled code that is working. So I'm going to show you a sample program that's written in the VS Code, and going to just show for you some lists of items that are stored under variable names. So arrays and lists are various ways to store multiple items of data in one variable name. And here are a few examples from arrays and lists. Let's go to this VS Code sample here. So here's quite a lengthy kind of program. But one thing to just remind, any lengthy thing is a bunch of shorter things. And so this is a bunch of computer concepts just repeated. And right here, let's see, where's a good one for an example. I'm declaring a list, an array list of current prices. The current prices in my program is a collection of prices for various companies. And there's a number of them, so I declare it like this. And this is one way to declare multiple items in one name, or one variable and name. And we can take a look at how that works here in our online compiler. Okay, for example, we can do this. How about string? Let's declare the names of the months. Maybe I won't declare all the names of the months. Let's just have 3 of them for the moment. And let's print the months and see what it does for us to begin with. Reach the end of file while we are parsing, probably because we're missing one bracket. There we go. All right, I just printed out the months and look at this. I got some strange language here. That's how the computer views this new variable months. It's some kind of string, and it has an identifier, perhaps an area in memory, in the computer's memory where it's stored. So what happened to January, February, and March? Let's try this. I'm using a little square brackets with a 1. And those of you who know computer conventions will be able to correctly predict which month will be printed out here. February. Wait a moment, isn't January the 1st? Well, it is commonly known that in computer science, we begin counting at 1. And here is a string array. This little double empty square brackets indicates that it's an array. It has several items in it. And the square brackets here just lets Java know to accept these items as multiple items in a collection under the name months. They're enclosed in curly brackets. That's a little distinct from some other languages where different shapes brackets are used to declare arrays. So that's something you need to remember, possibly. And the storage of this months variable is kind of strange if we look at the variable itself and print its value. But if we print the value of the first item in months, which is actually the second, we get February here. And how about months at 0? Starting our counting at 0, we should get January. And there it is. Now, these arrays are extremely useful. And when I grew up, I used lots of these arrays. There is a drawback from the arrays in Java, as they are here. They can't change size as they are at the moment. So if I wanted to add in April, May, June, it wouldn't let me unless I just declare it at the very beginning. So that is a drawback of some arrays. However, I did show you an example already. The structure that I'm using in this computer program here is not the same thing. It's called an array list, and an array list comes with some special methods for adding in items, subtracting items, and the like. So for example, I can use the .add method and add on something to one of my arrays, probably in there somewhere. Oh, there's an add all method. It's adding on to an array of things. So you'll see that many of the keywords or variable types that we use have their own built-in methods that help us to get more done. There's an add, for example. There's a item, and it also has multiple things in it. It's a parent of these children, and onto the children, we're going to add a sign out link. So studying code like this might be confusing at first, but you will start to recognize elements of what you've been learning from your grammar lessons in this poetry, for example, or this writing. All right, so worry not if you don't understand everything here. Just look for some of the things you may already know about, and gradually the rest will be filled in. Okay. There's a little introduction to arrays. You can look into arrays and lists, and you can find ways to work with them, and they're very useful because you can use one variable name, but store multiple values in that variable name. So I won't go into too much more details about lists or arrays. Suffice it to say you may research them and use them when necessary. I found it very useful to use arrays and lists at certain times in computer programming for FRC. When we're collecting data from a camera, for example, we need multiple values to be collected. And so I use an array or a list in that case. All right, how about making decisions in our programs? Well, here are some keywords that you find in Java and structures that you find in Java for making decisions. And our discussion of operators and comparisons in particular will be very useful in this regard, because our if and our if-else statements and our if-else-if and else statements, those are three different levels of if statements described here. Each one of them has conditions that arise or are evaluated through comparisons. And now we can see how some of our code will fit together. We're going to have a Boolean expression evaluated out of a comparison operator and two variables in our if statements. And they will either be true or false. And if they're true, then the if statement will execute an action contained in some brackets. The if-else statement has two possibilities. Either it's true and one action happens, or it's false and another action happens. And the if and else if statement with an else at the end can have several conditions that are evaluated, possibly true, and one other action for all other cases. And more sophisticated yet is our switch statement, which allows us to evaluate multiple possible conditions, some of which may both be true or both be false at the same time, and make appropriate actions if carefully put together. The switch statement is very powerful, but you also have to be very careful with the logic in switch statements. It can be confusing if you get something wrong. There we are, Java decision structures. Let's see what they look like in action, and we'll go back to our Java program here. So we'll go back to our A equals 6 and B equals 10. Oh, they have some slightly different values now. That's quite fine. Now our if statement. If A is smaller than B, then we can do this. we're going to print a little message. And there's our if statement. Let's take a look at our if statement and analyze the various parts. First of all, if is the keyword, and it's followed by some brackets. And inside the brackets, we have a logical expression, in this case, A smaller than B. And now we know from our discussion before, A smaller than B is replaced by either true or false. So if it is true, then this statement is going to execute. System out print line, A smaller than B. Otherwise, it won't do anything. So we know that A is smaller than B. We should get a little message when we run this program. A is smaller than B. We can expand on this and go down here. If A is smaller than B, we have this, else oops, remember the quotes. And the semicolon. Organizing your code in nice columns can be very helpful so that you know what level of bracket you're on. You start to see here the code is getting a little more sophisticated when we start to put these structures in here. If you always open your brackets and close them at a certain level, it's not strictly speaking necessary. For example, I can put all the bracket back here, it's still going to work. But when I line the brackets up nicely, closing and opening relatively close to each other, it can help me to just make sure my code is nice and neat and tidy. So that's not my focus at the moment, but just making you aware that keeping your code nice and neat and tidy will save you a lot of problems later, because you can well imagine that missing a bracket is one of the most common things that will allow a program not to work or cause a program not to work. All right, so we know that A is smaller than B, so we should get two statements saying just as much. However, if we make A 60 now instead of 6 and try the same thing again, the first statement is completely ignored. And then here we find out that A is not smaller than B. And we will try one more of these statements, just like this. I'm going to copy it and paste it. And we're going to have one more structure here, else if A is equal to B, in quotes. I can do this and system.out.println. How about A is equal to B? And there is a separate condition. Now we have three conditions being evaluated in our program. If A is smaller than B, A is equal to B, or else. And let's try A equal to B. The first statement is not going to do anything. It's not smaller than B, but the third statement, oh, there's an error. And I just missed a print line somewhere. Print line, just remember the T, and hopefully this will work. A is equal to B. A is not smaller than B. And there we have our three possible levels of if statements. I believe you can put multiple else ifs in the middle as well. And that will help you to make more complex decisions. So that's our decision structures. I think in terms of switch, I'm just going to let you know that switch is another one that you can do. It's a little more sophisticated. And of course, you can find such things as switch over in your tutorials. There's an example of a switch expression, case X, Y, and default. There's all kinds of possibilities. Here's an example: is day equal to 4? Well, there are actually 7 possibilities from Monday through to Sunday, and this one's going to print out Thursday, day 4. So referring you to your tutorial there. All right, just take a pause here. So we have some rather advanced discussions about game programming. Yes, and so there's a very nice question about the string. I'm going to come back to this string question. If we do not put this double brackets in front of the string, let's find out what happens. It's going to say, what? Oh, array required, but string found. So we need to declare this as an array. This is distinct from a string. Those 2 square brackets are necessary. There we go. So the purpose of switch is possibly just a different style for an if, else statement. It's a lengthy structure, or a structure that allows for lengthy sets of possibilities and decisions. So here's the switch statement, and there are 7 possibilities. They're just called cases. It puts it into a very regular and neat syntax with colons and break statements. Takes a little longer to write it out, but it allows for a very clear set of cases to be established for possible decisions to be made. So I think of the switch as a lengthier if, else statement with multiple or numerous possible outcomes. So the else statement, I believe there may be an else statement in the switch default. Instead of else, it's called default, and we see that here. All right. Just 1 or 2 more little topics to discuss this evening. One is called loops. And computers are really good at repetitive tasks. And if you ever see your computer code starting to repeat, chances are you can put it into a loop and save a lot of work. So for example, if I wanted to print the numbers from 1 to 3, I can do system out print line 1, system out print line 2, and system out print line 3. But imagine trying to print the numbers from 1 to 1,000,000. I don't think anyone has time to write out 1,000,000 print line statements. However, a loop will do just that for us with only 3 lines of code, as we see here. A loop has an initial condition. I declare a variable that's temporarily used only inside this loop. In this case, it's the integer variable I. And the I is going to start at a starting condition. The initial condition is 0. And the ending condition, as long as I is less than 5, we're not ended. As soon as it is not less than 5, as soon as this statement is false, then we end. And we alter the variable by some means, by some assignment operator. So one of the most common one is just the increment operator. And we, every time we go through the loop, the value of I increases. All right, so we can take this code here and try it out in Java. Just collecting a little bit of code for later. All right, so this is code about loops. And here's our first loop, the for loop. We declare a variable for use inside the loop, and we set its initial condition. We have a statement evaluated for the final condition. And then we have some kind of modification of the value of the variable. In this case, we're incrementing it by 1 every time we go through the loop. And in here, we can do whatever we want. A common thing to do, at least, is to print something so you can see what's happening. And in this case, we're going to print the value of the variable I. It's going to start at 0, and the loop will no longer execute when this is false. So when I is 4, it's less than 5, it will print 4. But when I is now equal to 5, this is now false and it's done. So we're only going to get the values 0, 1, 2, 3, and 4. Hopefully, if I remembered all the parts there, 0, 1, 2, 3, and 4. The beautiful thing is, as I was mentioning, you can put a much higher number and it will do the same work, or it takes the same amount of work to do much more. For example, here we are all the way to 10,000 less 1, and we go to 9,999 in a matter of a few moments. So computers are quite happy to do this. Now, one thing to remember in FRC programming, loops like this are happening maybe 100 times a second as the robot is moving on the floor, and maybe 100 times a second it's checking whether you pressed a button on your game controller or whether the motor is finished its task. And that's something that you will find in the computer architecture of the FRC robots. 100 times per second, your code is executing in a loop, and you make a decision about 100 times a second and keep that robot on course to do what it needs to do. There's our first loop. Now I'm going to modify this a little bit. Go back to maybe 5. And I don't have to use the increment operator. I can say something like this. I is equal to I times 7 plus 3. This is the math statement that makes the math people a little bit irate, because I is never equal to I times 7 plus 3 in mathematics. But again, this is the new value of I is the previous value of I times 7 plus 3. So the first value of I is 0. Then the next one is going to be 0 times 7 plus 3, which is 3. Then 3 times 7 plus 3, which is 24, and so on. And we'll stop once I is 5. It's going to stop pretty quickly. 0 and 3. It didn't actually print all that many, but let's try and let this go up to quite a high number. And it's going to every time multiply by 7 and add 3. And we go up to 171. Something happened there. It may be because I'm using an integer. So if I want to count higher, now I'm running up against a limitation of my integers. Maybe they're not going high enough. So let's try this. How about I do long I? It's still doing the same thing now, isn't it? The I is still working as a long, but we're stopping at 1. Oh, that's why it wasn't printing down all the way, or it wasn't showing. And there we are. If I add a 0, it may get us one more iteration or repetition here. There it is. And it went all the way to the highest number that's lower than, what is that, 10 million or so? And then the next repetition, the value of I exceeded that number and the loop stopped. So the short of it is, my loops can be simple, and I can use just an increment operator like this. Or I can use a more sophisticated mathematical expression to get different effects. And there's my 1,000 numbers. Output up till 999. And you see there's the last one. So remember, this only executes while it is true. As soon as it is false, it will no longer execute and the next statement will not repeat. We break out of the loop and we go to the next line. So here's something to be clear about. How do loops work? System.out.println, beginning of the loop. And you can see when we're finished, it will execute this statement, end of the loop. And let's just put this down to 10 again and run it. There we are at the beginning of the loop. We are there. And then we print out 0 all the way up to 9. And then we break out of the loop and we're at the end of the loop. This is something called order of execution, and it's a very important concept for you to understand. How is your computer code going to go? This loop repeats this statement each time with a different value of I. You really can benefit from thinking about this deeply, how this works. This is one of the magical aspects of computer programming that give computers great power. To execute the same code with different values of I gives us great power in our computer programming. There's our Java loops with 4 statements right here, but we also have them with while statements. And in this example, I've put an initial condition, an end condition, and I've altered the variable for the same 2 sets of numbers being output as with the for loops. And you can study this later, how these while loops will have the exact same output as these for loops. And they also have an initial condition, an end condition, and they alter the variable just in a slightly different format. So now there's an interesting thing here, a question. Why is there no differing feature between the new I and the old I? It can get very confusing if you look at it, especially with your mathematical thought process. You always have to come back to the new value of I is 7 times the old value of I plus 3. And if we think like that, we'll do this. I is 10, whoops, and we're going to print. When I is 10, we'll print 10. Now we're going to say the new value of I is 7 times the old value of I, 70 plus 3. Now it will be 73. And then we go here, and then, we're going to print a 73, and then we're going to say, 7 times 73, which is like 513 plus maybe another 3, 516, and so on. And then it checks, are we still less than a million? Yes, it keeps on doing that. So I'm not sure if I've answered this question, no differing feature between I and the old I. I'm just trying to emphasize my thought process. Maybe you might ask a different question or a similar one if that might help to clarify more. All right, so that's Java loops, for loops, and while loops. I'm not going to introduce or test the while loops here, as they're very similar to the for loops, and you can try them out on your own. The final thing I would like to look at here is Java methods. Here is the main class of a Java program, and in here, the main method. And in here is a secondary method called count to 10. And this method may be used to count to 10 in a program. And there's the collection of code. I highlighted it. Every time I want to count to 10, I can do this code and I can call it in a method. So here I go in the main program, count to 10 once and count to 10 twice. When I count to 10, it skips over here, goes through this loop, the 10 times. When it's done, it says, we're done. Where did we come from? Oh yeah, we came from here. Then it goes back here. So this gives a detour, does a little repetition in this detour, comes back here and executes this. And then we go to count to 10 again, and you'll see that. So the concept that's being emphasized here is order of execution. It's important to know in what order are these statements going to execute. And we'll demonstrate this with a little output here in a moment. So methods are blocks of code that accomplish a particular task and are executed as needed. They're called within a program. here's our method, private static void count to 10. And here's the call to count to 10 right here and here. So I'm going to copy this code. Hopefully it will survive the copying and pasting into our online compiler, and we'll see if this works. Whoops, we just missed a C there. And we'll see if this works now. And let's analyze what's happened in our program. All right, so it says hello world, because I started with the hello world program. Then I told it to count to 10. Then we see it counting to 10. Then I say, we just counted to 10. There we are. And then finally, a second counting to 10. We just counted to 10 again. And the program is finished. And let's look once again at the flow of this code. When you execute this program, the main method within the main class is going to execute. And there we are. This is the main method. 1, 2, 3, 4, 5 statements. They execute in order. It just turns out that 2 of those 5 statements, the count to 10s, they actually refer to several other statements in a method. So there's this repeated for loop here, and it's called twice. So you can imagine a little focus going through the program and showing which lines of code are executing in order. As it counts to 10, it's doing these. And that's called tracing. You can actually trace through a program and see the program executing in order, and it will highlight each statement as it's tracing. You may want to try this in your editors to become familiar with this concept of order of execution of the commands of a computer program. There we are. That makes everything for this evening. And I will post all of this here. Little home fun for you to look up some Java keywords. And there are some of the examples we've seen already on our discussions: if, else, for, while, int, double, and so on. There are many more on the internet. And it turns out these keywords cannot be used for variable names. So be very careful if you try to call while equals 5. It may give you an error of some sort somewhere. So be very careful. That's the keywords in Java. One thing that I'm preparing for future sessions, the FRC is a very motivating competition, because it's A, a competition, B, it's a co-opetition, and C, well, that gives you a short timeline and an element of excitement. So the competition that I'm preparing, just give you a little sneak peek of it. I already have a few times. This is a computer program under development. It's going to be a game. And we're going to hopefully be able to write some Java methods to compete in this game as autonomous entities. So each team or individual may submit a method, and we'll have a little tournament. And this will be a very easy tournament to participate in. All you need to do is to create a method that returns a single number between 1 and 100. So it's very easy to participate. The challenge is, can you make your method strategically choose those numbers between 1 and 100 in order to have the best outcomes in the game? And I'm not going to say anything more about the game. It's a game I made up, so you won't be able to search it on the internet because I made it up in my classes. But I found it to be a very exciting game, and I've played it at university and with children of 6 to 10 years old and everyone in between, and everyone seems to enjoy this game. It gets quite competitive. So we'll try a virtual tournament this time, maybe in the next month or so, once we've practiced all of these concepts in Java. So that will hopefully give us a motivating factor. Not only will we learn enough Java code to compete in the game, but that will also bring us closer to being able to understand and implement FRC Java code. And I've carefully chosen the game also to align where possible with the FRC Java concepts so that we're moving in that direction. All right, there are some references, and this will be posted on the internet so that you may take a look at some of the places where I've taken my information. The Java T-Point is an interesting website. The English grammar is not perfect in the website, but the content is quite rich in Java. So I've included it there anyhow. And there are a few other references for your enjoyment. All right, let's take a look at any of the questions here. A function is a piece of code that is called by name. It can be passed data to operate on. Parameters or arguments, yes. And can optionally return data, a return value. All data is passed to a function is explicitly passed. A method is a piece of code that is called by a name that is associated with an object. So that's someone from Stack Overflow. And as we discussed last time, some of us have different either understandings and or uses of the words method and function. I've used them interchangeably. I tend to use function when I'm talking about Python and method when I'm talking about Java. But as this shows here, there's a little bit more of a precise understanding possible through that definition that was provided there. So you would want to make your method static, so you do not need to make an instance call to call your method. And there's some concepts that we'll be getting into a little bit as we go. You'll see the word static happens quite frequently in computer programming with Java. Well, here we also have the word public. We have private and public. Those are other words, static. And these are words having to do with the organization of the methods and programming code in your programs. So we will discuss those a little bit more. You'll find, like I found when I was learning FRC Java, I learned Java through FRC. And at first I didn't know what static meant. I just sort of copied it wherever it seemed to be made, and it became easier to use a little later on. And I'm sure you'll find the same. So now the link to the PowerPoint, I will see if I can post the link to the PowerPoint here. I'm going to stop sharing my screen, come up on the PowerPoint. So I've made it anyone with the link can view, and I should be able to put this now in the chat. Oh. So there's some discussion of functions and methods. There was also some discussion here about static methods and functions and parameters and the like, and we will surely get to that a little bit more. We've just now begun to speak about methods. All right. So there is no difference between a method and function in Java. According to the discussion there is, as one of them involves passing a parameter in and out and one doesn't. A method may take a parameter and pass one back, whereas a function may just do something. But we can become a little bit more precise in understanding of those in a future discussion, as we'll surely have time to explore things like static methods and public and private methods and the like, as we explore more topics moving towards our FRC code. All right, so our home fun will be, of course, to explore these ideas in Java. And I think this will be a good set of material for you to discuss and study together, so that eventually we will be able to maybe play a game where we have everyone who would like to participate submit probably in this case, a method that takes in some data and returns a number. Okay, so there we are with our What kind of data? Well, that's the whole thing in Java. There's a lot of flexibility. Any of the data types that we have already seen can be taken into a function. And if there's too much data to put in there, we can make our own data type. For example, I could give it the name, the address, and the phone number, and those 3 pieces of data. But what if I'm talking about a person and the person has 100 pieces of data, like in some school database? Well, then I can pass a special class in called a person, and that person has 100 pieces of data for each person. And so the kind of data is only limited by our imagination and our coding ability. In this case, in this game, we're going to pass some information about what the other teams chose for their numbers, and then get some educated guess as to what's a wise number to choose for the next round. So what kind of input? That's right. I think that's what you mean here, the input. So you can input all kinds of things into a method. It just depends on what you're asking for and what your program is designed to do. I'll give another example here. In this program, there are a few methods. Is this the... Okay, so here's a method, the start method, and it takes in a stage. This is actually a graphical program. So it takes in what is like a stage. It's like a theater stage as its input. So that's a complex data type, and so it's capitalized. I'm going to go to another part of the code here, and there are a bunch of methods in here. Here's a turn, and it takes a list of floating point numbers called the prices. That's the input prices. And there's the method. It calls a bunch of other methods, and then it's done. Here's another method. It's called validate. It validates the code and then comes up with a return true if it's valid prices, and it returns false if the prices are not valid. So to answer what kind of input depends on our method. In this game, the kind of input is going to be a set of prices from the different players. And we see a whole bunch of methods here in the computer code. Hopefully by the end of our series of coding sessions, we'll have a better grasp of what this program does, how it works, and thereby be much closer to operating similar code within a computer program for a robot to be driving. Can you call methods from different files? Yes, in fact, you can. In this case, for example, my program here, my VBox and HBox, I actually got that off of an online tutorial. And right here, I make a call to a new class called GPCG. And there's the GPCG class. It's in a different file. And when I go there, this is the code for the GPCG. And you'll know what that means later. Now, when I want to use this, I'm calling it game, I can call a method inside the GPCG file, like set rounds or set players. Haven't implemented that yet. It's coming up. So yes, you can call methods from a different file and from a different class. Usually code in a different file is located in a class, and I use a dot to get at the methods inside that class. So game is the class and set rounds is the method, and I use a dot to set the rounds using the set rounds method. So okay, so there's a question here from here. What data and how it relates to what the competition is. So if we're talking about this mini competition that we're having, this little cooperation, the data that will be input into your method is just a set of prices. But if it's how it relates to what the FRC competition is, well, then we will see that the structure of the programming is similar to the structure of the classes and methods in a FRC program. The mini competition, yes. So the data is just going to be an array or list of floating point numbers between 0 and 100, and possibly a few other numbers to go with them. And then the output is just going to be a single number between 0 and 100. So members of our FRC community, once again, your participation this evening in the chat was most appreciated. And if you have additional questions, please feel most free to email. Very glad to do some troubleshooting. My task now will be to share some of this code that we've generated this evening in a few separate files and to send out some links. You will see on the First Robotics Canada website, there's a playlist called Java Coding, and data and references from this and other coding sessions will accumulate there. I'll try to put in the information for the links, some links to these code examples. And eventually when we all get into our GitHub, then we can share this code on GitHub and you will be able to see it on the internet. There we are. All right, so very nice to see everyone this evening. I'm just going to stop the recording.